Welcome back. In this class, we will continue with measurement. If you could remember, in the last class, we discussed everything about unit, what units are, and how to do unit conversion. And you remember in that class that the basic principle behind unit conversion is how to remove prefix and how to impute prefix. You remove prefix by changing it to equivalent value, and you add prefix by applying the rule of 1. That is, a number divided by itself is equal to 1. And you know virtually that every number is multiplied by 1. Now, in this class, we continue with measurement. But before we talk about measurement in details, we want to look at what we use to take measurement. You know that we take measurement with measuring device. And if there will be anything that we are going to use to take any measurement, that object must be calibrated. Therefore, we need to understand the nature of everything that we use to take measurement that we know as calibrated tools. Now, let us begin. Calibration of measuring device. How do we calibrate measuring device? Measuring devices are calibrated naturally by the manufacturer of that device. What we need to know about that item that we call measuring device is the value of individual stroke on that device. What I mean by that is this. I want you to look at this ruler in this diagram. You will see that there are several strokes of line on it. Some of the line are more longer than the other. Some of them are numbered while some are not. But irrespective of being longer numbered or not, each of these lines have individual value. Each of these lines have value. And the value of that line, of each of these strokes, is called accuracy. And in order to understand or to know the value of individual line, which is the value of accuracy, we need to apply this formula. Difference between adjacent value divided by number of stroke between the adjacent value. Adjacent value means value that are very close to each other. For example, let us take value between 0 and 1. How many stroke is between this 0 and 1? If we count from 0, we will count from 0. 0, 1. Let us count together, please, so that we can know what we are really talking about. Let's count together. So this is what is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 strokes between value of 0 and 1. So what do we need to do? We take difference between adjacent value. The adjacent value is 0 and 1. What is their difference? That is to say, 1 minus is 0. Then we note the what? Number of strokes between the adjacent value. The number of strokes between them is what? Is 10. By doing that, we are having what? 1 divided by 10. This is equal to 0.1. The meaning of this is that accuracy is equal to what? Is 0.1. And that accuracy means the value of individual stroke. So this one is 0.1 by value, 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 this one is 0.1 by value. Now let us now see how we need to add them together to up to 1. This is 0. Oh yeah, add is 0.1 to 0. That's equal to what? 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.91. That is to say, if you are going to look at the value at this point here, or you want to look at the value, this is 3. You are now going to count how many strokes. 3.1, 3.2, 3.3, 3.4, 3.5. That is, this line is 3.5. So that is the accuracy. Therefore, what is the error that can occur on this particular measuring instrument? It will be accuracy divided by 2. So if I divide the 0.1 by 2, that will be what? Let us do the calculation. 0.1 0.1 divided by 2. So what I need to do is to multiply everything by 10. It should not be what? 1 divided by 20. Because I want to work with whole number, not fractional number. So you multiply this one by 10, you multiply this one by 10. So answer is equal to what? Is 0. So because how many 20 goes in 10 in 1 is impossible. You had 0. Once you had 0, you have 0. How many goes in 10? How many 20 goes in? Is impossible. You had that. And you had that. So how many 20 goes in 100? That is 5. So the error on this instrument is equal to what? 0.05. So what is the unit? The unit is what? Mm. The unit is what? Mm. You look at the unit on the measuring instrument, and you know that you can convert this one to centimeter. I know you can do that. Can you prove it to me? But if you know that you can't prove it to me, okay, let us convert 0.05 millimeter to centimeter. Are you getting me now? So yeah, let us do it together to practice what we have done in the past. So now we want to convert 0.05 centimeter. Sorry. I'm too glad to do this. Millimeter. We want to convert it to what? We want to convert it to centimeter. Now, what do we need to do? We want to convert millimeter to centimeter. The first thing that we need to do is that this milli, we have to remove it. We have to remove it and bring in centi, isn't it? That is it. Oh yeah, remove milli. How do we remove milli? We remove milli by interpreting it to its equivalent value. And the meaning of milli is 10 raised to power minus 3. So that is to say, this value here, 0.05 millimeter, is to be equal to what? It will be equal to what? 0.05. What is the meaning of milli? Milli is equal to what? 10 raised to power minus 3. Yes, meter. Is that not it? But we are not to convert to meter. We are to convert to centimeter. That is to say, we need to bring in centi. How do we bring in centi? We apply the rule of 1, that is C divided by C. How do we do that? 0.05 times 10 raised to power what? Minus 3. Minus 3. Oh, centi divided by what? Centi and milli. You know that this centi must be prefixed to the main measuring letter. That is to say, it must come immediately before that meter. So with respect to what you are saying, we have already have what we call centi. Is that not it? We have centi already. But look at this C. Do we need it? We don't need this C. So to remove this C, we interpret it to its value. And the meaning of centi is what? 10 raised to power minus 2. Oh yeah, let us do that. We are now having what? Now, remove the unwanted C, which is the denominated C. We now have what? 0.05 times 10 raised to power minus 3 centimeter. Yes, divided by what? Divided by 10 raised to power what? Minus 2. Now, you now bring this 10 raised to power minus 2 to what? Numerator. It will become 10 raised to power 2. So, what are we going to have? We are going to have 0.05 times 10 raised to power minus 3 times 10 raised to power what? 2 centimeter. So, if we are now deceiving ourselves, minus 3 plus 2 answer is equal to minus 1. So, this 10 will become 10 raised to power minus 1. Automatically, what are we going to talk about? We are going to say that we have 0.005 centimeter. So this is going to be what? 0.005 centimeter. So this is the value of error in centimeter. So you have now understood the process of calibrating your measuring device by trying to determine the value of each individual stroke. And the value of each individual stroke is called accuracy. Then that accuracy, if we divided by it by 2, we are going to get the possible error that will occur on that particular measuring device. And why do we report error? How do we report error? Whatever measuring value that we have taken, let's assume that you take a value of 4.6 that is 4.6 at this point. Not this is 4.5, this is 4.6. 4.6, 4.6. We are now going to add and subtract error, which is equal to what? 0.05, 0.05 mm. So this is the full and correct interpretation. This actually means that the value can be increased by 0.005 or it can be decreased by 0.005. But in calculation, in computation, that plus 0.005 is not really, may not really affect. So that's the reason why we use 4.06. But if you needed, you need to include your particular error. So these are other measuring devices, and what I want you to do is to try to calibrate them to find the value of each individual stroke. This is vernier caliper, this is a spectrometer. You can see that this measuring instrument, they have two scales. They have main scale, they have minor scale. This one have main scale, this one have minor scale. But this one, it has only one scale. Now, for the measuring instruments that have two scales, how do we take the measuring value? There is a way that we do that. And I think I should illustrate the example here before we get to how to use vernier caliper and micrometer screw gauge. But it does not limit to vernier caliper and micrometer screw gauge. This device that you see here is called spectrometer. It is the one that will give you the angle of dispersion of spectrum of light. And by calculating the angle, you can be able to say that as angle of incidence divided by angle of refracted, and you'll be able to see the refractive index of that particular spectrum of light and among its own spectra. So what we are trying to say here is that if you look at this thing here, what is the measurement that this particular machine have read? So now let me clear the board so that we can see what we want to do. Now, in order to do that, this thing is calibrated in degree, but it is not shown. I know it. Are you getting me now? I know it. But majorly, difference between the main scale and individual scale is about 0.1. I will tell you the meaning. You will see the meaning of what I'm talking about now. But just follow me. But this is 0 degree. This is what? 20 degree. This is what? No. This is 10 degrees, sorry. But it is not shown. I know because the difference between this one is 10. So automatically that 10 should be consistent. This is 10 degree, this is 20 degree, this is 30 degree, the next one will be 40 degree. But let us see, what is the value of each of these strokes here? Between 20 and 30, let us see how many strokes is there. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So between 20 and 30, there is what? 10 strokes. And the difference is what? 30 minus 20, which is equal to 10. 10 divided by 10, answer is equal to what? 1. So that is to say, the value of each stroke is 1 degree. The value of each stroke is 1 degree. The value of each stroke is 1 degree. Listen, the value of each stroke is 1 degree. Now, you have seen the main scale. You have known the calibration of the main scale, that value of each one is 1 degree. So once you have seen your main scale, you need to look at your minor scale. How do you take the value of your main scale? The value of your main scale is determined by the value of your minor scale. And how? You will look at the number 1 stroke of your minor scale. In this case, this is 1. So the value in this place is equal to 0. You will look at the scale, you will look at the strokes that come before that particular 0 stroke of the minor scale. That is this reading on the main scale. That is to say, this is the major reading on our main scale. Are you getting me now? This is the value of the main scale. To know the value of the main scale, this is what? 10, 15, 16, 17, 18, 19. That is the value that is read by the main scale is what? Is 19 degree. The value that is read by the what? Main scale is what? 19 degree. Let us now look at the value that is read by the minor scale. You need two value. Value read by the main scale, value read by the minor scale. The value read by the main scale is determined by the minor scale. Are you getting me now? And to know that, you look at the value, you look at the stroke on the main scale that come before the stroke of a 0 scale of the minor scale. How do we do that? You look at your minor scale. You look at the zero value. You look at the stroke that comes before that zero value on the main scale. So that is the value of the main scale. This case is equal to what? 90 degrees. Let us now look how to read the value of the minor scale. In order to look at to read the value of the minor scale, you look at the line on the main scale that coincides directly with the one of the stroke of the minor scale in the universe. No matter whatever value you read, two lines can never coincidence. Only one line will coincidence. Let us see. Which line coincidence? This one is not, this one does not, this one does not. You will look very well until you meet a line. Do you see? This is the line that actually coincides. Are you getting me? That is to say, the minor scale and the main scale line coincide at this point. So to read the value of the minor scale, you look at the point where the main scale and the minor scale coincide, meet directly. That is the point of the value of the minor scale. And let us now see what is the value in this place. What is the value in this place? So the number of stroke here is 10. So this value is about 8. Are you getting me? But it is not 8. It is not what? 8. It is 8 divided by 10. That is to say, every minor scale value that you read, the number of strokes that you read, you are going to divide it by 10. Divide this one by 10. Answer is equal to what? 0.8. That is, the value here is equal to what? 0.8. Now, the full reading that you are going to have, is equal to what? Main scale reading plus what? Minor scale reading. That is to say, 19 plus 0.8. The full reading is equal to what? 19.8. That is to say, it's not up to 20 degrees. So the value on this scale that is read is what? 19.8. Let us now look at this guy here. What is the value on the main scale? This is a zero scale here. The line that comes before it is this one, which is this one immediately here. Are you getting me now? So this is 15, 16, 17, 8. Let us see the value between this one. 15 and 20. The value is what? 5. Are you getting me now? How many strokes? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we have 10 strokes between 5. Let us now say that, okay, difference between that adjacent value is 5 divided by what? Number of strokes. What is answer? Answer is equal to what? Is 0.5. That is to say, the value of each stroke is equal to what? Is 0.5. Let us now see. So this is 15. This is 15.5. This is 16. So the value read by this one is equal to what? 16. Let us look at the value read by the what? Minor scale. Wow. The minor scale of this, it read up to 50. Well, there is no problem. We are going to find the value. Let us find the stroke that is coincidence. Did this one coincidence? No. This one, no. This one, no. This one, no. You look at the stroke one by one. Yes, this is the stroke that coincidence. Do you see? I found it. This is the stroke that coincidence. Any other stroke is not. Are you getting me now? That stroke, if you look at it, this is 5, 6, 7, 8, 9. You are now going to divide that 9 by what? By 10. So this is equal to what? Is 0.9. So 16 plus 0.9. Answer is equal to what? 16.9. So the value that is read by this is equal to what? 16.9. So that is about how to use a scale that have two measuring scale. A measuring device that has two scale, main scale and minor scale. So they can call the main scale any name, they can call the minor scale any name. For vernier caliper, this is what we call vernier caliper. The minor scale is called vernier scale. Are you getting me now? So let us go on. This is also your pipette in your lab. This is this is burette. This is measuring cylinder. This is burette reading. This is your burette. So let me magnify it so that you can see. What I want you to do here is to calibrate this particular value and get me the accuracy as well as error that can possibly arise on this measuring instrument. You can pause the video and do that. If you get it, you are good. The same thing. Do the same thing to this one as well. Find me the accuracy as well as the error. Do the same thing to this one as well. Okay? So you are going to see the next thing. Now, another thing. Now, after we have seen how to calibrate our instrument, we now need to talk about measurement. What is measurement? It is the process of determining the number of observation of or event. It is the process in which the amount of values, properties, or quantity is obtained. Are you getting me? Amount of value or properties or quantity is obtained. What is the meaning of that? Everything that you want to measure is either you want to measure the amount, property, or quantity. Okay? Measurement is an important activity in physics, in chemistry, in mathematics, any philosophy of calculation. During measurement, in fact, in biology as well, during measurement, a scientist follows the proper procedure, uses proper instruments so as to get value that is very close to the exact value. Do you see that? That is to say, if you use any measuring instrument, if you use any instrument anyhow, you are not going to get appropriate result for your experiment, and that will lead to waste of effort. Some experiment is so cumbersome that repeating them may be something that you won't be able to perform. Note, no measurement is perfect, which you know, and that is the reason why we report error. Time measurement now. We want to measure time. Time enables us to plan our daily activities. Time can be measured in seconds, minutes, or hour, day, year, and so on. And you have seen how we convert year to seconds. Time helps us to know our age as well as historical event. It is good. It is also help us to control the account. You see, all these things are just something behind time. Are you getting me now? But I must let you know that time, it is the difference between day and night. We can visualize time as light. If it is dark, if it is full light, you know this is the time. But without light, you cannot determine time. It is the process of light that scientists were able to build our stopwatch, our watch, our clock. Without light effects, they can't do that. And that calibration has been done in order to synchronize with our light. Measurement of length. We have talked about measurement of time. We are going to talk about measurement of length. And you know that time can be measured with what? Stopwatch, clock, wall clock, wristwatch. Measure any watch that you know. Okay? So now we have what we call length, measurement of length. What is length? Length is distance between 2 points. Distance between 2 points. You have 1 point here, you have 1 point here. Distance between them is known as what? Length. Don't worry, we are still going to talk about coordinates in mathematics. That's the reason why in some of this lecture, I will go to some of the advanced area of mathematics, because I will deal with geometry specifically, because area of geometry gives students a lot of problem. I myself, I don't know the importance of geometry, not until when I become programmer and I begin to program all these geometrical objects. That is when I know the importance of geometry. In fact, geometry in programming, it's beyond something, it's beyond programming ordinary geometrical objects. If you want to design anything, any object, you want to design forest, tree structure, anything, we use trigonometry to do that, because it is one that will enable us to know the extent of line and the direction, which is the angle. So don't worry, we are going to deal with that, and you are going to see the basic analysis. In that lecture, I will give you the hierarchy of geometry. You don't even know that geometry have hierarchy. Don't worry, I will teach you the hierarchy, and we are going to use the hierarchy to combat the problem in every aspect of geometry, which will give you a very wide, broad knowledge about geometry. So now we have length. A length can be straight or can be curved. Are you getting me? One of the curve is arc, circle. That is 2 dimension. I must say this is 1 dimension, circle is 2 dimension. So when we are talking about straight line, we have vertical, we have horizontal, we have slant line. That is, we have vertical, we have horizontal, and we have slant line. That is the 3 type of what? Straight line that we have. And these are the 3 basic lines that we are going to use to treat subject on dynamics. You will see that everything that you think that it is difficult, I can't handle this. When you see the basic principle behind them, you will be very offensive that is it something that they are telling you that is very difficult? Don't worry, it's because you don't know the key behind them. When you receive the key, you will be able to tackle them. So these are the various measuring devices. You can look at them, look at their name, and look at what they are doing for us. One of these days, you will meet one of these in laboratory, and we might have come through one of these in your real life. So this is the vernier caliper. You can see the diagram, how it look like. Standard vernier caliper. This is how it look like. And if you want to see this instrument, go to people who join mentor together, whether in your environment. It is not, this is matter of excursion because you are a scientist. Tomorrow you are going to be building things. So you need to be familiar with the tools that you are using. Go to a very nice weather, tell them that you are a student, or pack yourself, you and your colleagues, students in your school, group yourself in 10, go to a weather shop, greet them very well, like a good student with culture, with a well-trained character. Greet them with honor and explain to them what you need to know. I promise you, you will receive knowledge, and you will be in fact you will be happy that wow, you are a scientist. Yeah, I drew. So in this case, you have seen this instrument. This is vernier caliper. Why this one is micrometer, screw gauge. This instrument is also used by welder, and they will tell you how to use them and how to use them to take their measurement. This instrument is also a two-scale instrument. It has linear scale, it has rotational scale. So this scale rotates while this scale is a linear. So once this one rotates, it can move forward or backward. So therefore, you should be able to know, you should be able to know what it is all about in the procedure of measuring using micrometer, screw gauge. So these are some measuring value using micrometer, screw gauge, and vernier caliper, and we should try to look at their value. I want to let you know that the micrometer, screw gauge, you read in mm, and each of the value here is 1. This one is 1. This one is 1.5. This one is 2. This one is 2.5. This one is 3. This one is 3.5. So the linear scale in this case read 3.5 mm. Are you getting me now? So you are going to see which line. This is the line of coincidence. Are you getting me now? With one of our rotational scale reading. If you can read it, this is the line that coincidence. If you want to read that line, this is 35, 36, 37, 38, 39, 40. So each of these line is 1 unit, and you know how to determine that. If you see that it is cumbersome, you can use that procedure. This is 35, 36, 37, 38. So the value that is read here, the value of point of coincidence is what? Is 38. But it's not 38, you divide it by what? By 10. It's equal to what? 0.38. So that 0.38, you add it to what? 3.5. So 0.38 plus 3.5. But if you press your calculator, you are going to get your answer. And if you don't want to press your calculator, you know how to do that, because we don't have much time. We need to do things as fast as possible. So let us see 3.5 plus what? 0.8, 0.38. Answer is equal to what? 3.88. So the reading on this scale is 3.88. Okay. So what is the reading on this scale? This is 5, 5.5, 6, 6.5, 7, 7.5. So the main reading here is what? Is 7.5. And the coincident reading, what do we have as coincident reading? So this is the line of coincident reading: 20, 21, 22, 23, 24. This is 24 divided by 10, which is equal to what? 0.24, 0.24, 0.24. So you had 7.5 with 0.24. So that is equal to what? 7.74. So the reading on this one is what? Is 7.74 mm. So the reading on micrometer, screw gauge is mm. So you can use that procedure. I have done something like this for you before, but let me do this one. You do this one by yourself. Okay. So let us see this. This is 3, 4, 5, 6. This is 3. And what is the value of each stroke? 3.5. 3. Okay. 3, 3.1, 3.2, 3.3. So the value read here is what? 3.3. The stroke I met before, that is 0. This is 3.3. Sorry. 3.3. The line of coincidence. Let us see. This one is not. This one is not. This one is not. This one is not. What about this one? This one coincides. This is 4, and that's equal to what? 4 divided by 10. This is 0.4. So 3.3 plus 0.4, that is equal to what? 3.7 centimeter. So the unit on this is centimeter. So that is how to determine the reading of any instrument that have two scale. Please do not forget this procedure. It's not difficult, okay? So let us see some our quantity. In this case, the next thing that we are going to consider is device and what they measure. You know that our wristwatch determine time. We used to measure time. Let us now look at some devices. Are you getting me now? And the quantity that they measure. Micrometer screw gauge measure the thickness of paper. Vernier caliper, diameter of small ball, or the in-depth of that small ball. Altimeter is used to measure height. Planimeter used to determine area. Please check the spelling very well. Pipette, burette, measuring cylinder, we use them to measure volume. Beam balance, chemical balance to determine mass. But weight, we use spring balance to determine weight, okay? Spring balance is used to determine weight. Current, we use ammeter to determine current, or multimeter. You can use any of them. We have speedometer to determine the speed or velocity. Accelerometer to determine the acceleration. We have spring balance to determine the weight. We have manometer or manus. The word manus means thing. Manometer to determine the pressure. So I want you to pause the video, look at all of these things and write them down. There are so many of them. These are some of them. You will pause the video and write them down and note those ones that you need to note, okay? They are very, very important. I am showing you step by step so that you will pause it and you will write it down. So that is the end of everything that has to do with measurement and calibrating measuring device. We are going to meet in other class. Thank you for listening. ABP.